This video is going to compare some of the syntax changes that are introduced with Java 9 when we compare it to Java 8. We're going to look at when we might want to use some of these new syntax changes and the benefits that it can bring us within our application code. If you like this video, please give it a thumbs up, and if you want to see more weekly videos on Java, please subscribe to the channel. So to begin, I've created this class called main, and I've got a public static void main method where we're just going to run some of our code and to compare Java 8 with Java 9. So first we're going to look at how Java 9 has improved on our collection factory methods. So if I just create a list of strings, and I'm just going to call this names list, and I've just created a list with 4 names in it. So we have Anthony, Joshua, Tyson, and Fury. And this is a pretty standard way that we go about creating a list or an array list with Java 8, where we define a list of strings using the interface class, and then we have this array list. But Java 9 allows us to do this in a slightly neater way. So I'm going to create this exact same list, but using the Java 9 way of doing this, which is using list.off. So I've defined names list at the top, and then just below I've defined names list 2, and this is using Java 9, so we have list.off. And if I just run this class quickly, we can see that the exact same names are being printed down below, just like a normal list. This collection factory method is also available with other types of collections. So for example, we can create a set, and we can also define a map. So I'm just going to create a map of a string to integer, and we'll call this name to age. And we will do map.off. And now every odd argument will be the key, and then every even argument will be the value. So if we have a name, let's just put Aneesh, and the age of 26. And then our second entry into that map will be Jude, who is 18. So these are 2 other ways that we might use this off keyword for the new collection factory methods. And one further point that I'd like to make on this new kind of way of defining our collection is that when we pass in values to this collection, they are now immutable. So that means these 3 collections that we've defined using the off keyword can no longer be changed. So for example, if I add to the names list, just like we would normally, there shouldn't be any problems. But if I were to try and add to the names list 2, which we defined using list.off, we will get a runtime exception. So you can see that this system out here has printed just fine because it's added my name. However, I've tried to add my name to this second list, and we've got this unsupported operation exception that is being thrown down below. So that's just something to be aware of when creating a collection using this off keyword, is that the collections will now be immutable. The second set of enhancements that are introduced with Java 9 are to do with the Stream API, and these are take while, drop while, and off nullable. So let's take a look at take while and drop while. So I'm just going to define a list of integers, and I'm just going to call this numbers, and we're going to do a list.off 1, 2, and then all the way up to 10. And I'm just going to print out the word take while so that we can see in the console when we're doing take while. I'm going to stream these numbers, and we can call take while, which will take a predicate. So I'm just going to put number, and number is less than 5. And the way this will work is that our stream is only going to process these numbers while the number is less than 5. So when we're using take while, and as we'll later see with drop while, the assumption when using these methods is that the stream we have is in an ordered basis. So this is really important, that our stream is going to be processed as if it were ordered. So with our first stream, we're going to take while the number is less than 5. So that means within our stream, we're going to take number 1, 2, 3, and 4. This predicate is no longer going to be satisfied when it gets to number 5. And the take while method is now going to assume that all of the numbers after number 4 are now equal to and greater than 5 on the assumption that our collection is ordered. So I'm just going to print these out into the console. And for the take while phase of our application, we can see that 1, 2, 3, and 4 have now been printed into the console. On the contrary to take while, we also have drop while, which will kind of do the opposite. So I'm going to stream the numbers, and then I will do drop while, and I will do number, and then number is also less than 5. And then I'm going to print each of these into the console. So drop while will behave in the opposite way to take while. So this will drop all of the numbers if they are less than 5. So it will drop 1, 2, 3 and 4. And then when it gets to number 5, it will assume that as this list is ordered, all the numbers after the number 4 are now going to be greater than and equal to 5. So then it will process all of these numbers afterwards. So we can now expect this second stream to print out 5, 6, 7, 8, 9 and 10. So we can see drop while 5, 6, 7, 8, 9 and 10. Now I'm just going to play about with these numbers a little bit so that we can see in a little bit more detail how take while and drop while are working. So if I change the number 3 here to the number 11, when we run take while, it's still going to assume that our numbers list is ordered. So it's going to process 1 and 2. And then when it comes to 11, it's going to assume that as this list is ordered, all the numbers are greater than and equal to 11. So it's actually only going to process numbers 1 and 2, even though we have the number 4 after 11 within this list. And then for drop while, it's going to drop number 1 and number 2. And then it's going to come to number 11 and realize that this number is greater than and equal to 5. So it will simply process the rest of the stream, that is from number 11 all the way up to number 10. So we can see that take while has printed 1 and 2, and then drop while has printed 11, 4, 5, 6, 7, 8, 9 and 10. The third stream method we're going to look at is called nullable. So I'm just going to create a list which has a null value within it. So I've defined a list of integers from 1 up to 9, but the number 6 is now null. And I'm just going to quickly run this application to see what happens. And we can see we actually have a null pointer exception within our application. And that's because we're using this new collection factory method of list.off. So this is another pointer when using the new collection factory methods with Java 9. If you're populating this collection with a null value, it will throw a null pointer straight away. So I'm now going to create a list using the usual Java 8 way. So we have our list of numbers and we can see that the number 6 has now been replaced with null. And what I would like to do is stream this list of numbers. I just like to double them and then I just want to print it out to the console. So let's see how we might do this using Java 8. So I'm just going to print out Java 8 stream, and then we'll take numbers null and we'll stream them, and then we will map them. I'm just multiplying each number by 2 and then for each, and I'll just print them out to the console. And of course down below we can see we have a null pointer exception from this null number. So usually what we might do is just filter out that null value. So we'll do number and then number is not equal to null. And pretty nice, so from Java 8 stream we have 2, 4, 6, 8, 10, 14, 16 and 18. So this is quite a common pattern that you have within Java 8 where you just want to take out some of the null values within your stream to avoid any kind of null pointer exception. But Java 9 allows us to use a new method called nullable, which will allow us to transform our stream to remove any of these null values. So I'm just going to print out nullable, and we're going to achieve this exact same outcome just down below using the nullable method. So again, we'll do numbers null and we're going to stream it, but rather than applying this filter, we're just going to map each of our values into a new stream of nullable. If I just run the application, we can see nullable down below where 2, 4, 6, 8, 10, 14, 16 and 18. So it's a very similar way of achieving this same sort of outcome where we're applying this filter. Now the final syntax change with Java 9 that I'm going to look at is involving private methods within an interface. And you might be wondering, why would we need to use private methods within an interface? So I'm just going to give this person interface a few basic methods. So let's say they do sport and they eat food, do hobbies, they visit shops and they do a job. Now one of the new keywords with Java 8 that were introduced were default methods, and default methods are backward compatible methods within an interface that all implementations of that interface now have access to. So let's say we have a default method which is involving doing daily activities, and just a regular person would probably do their sport and they would eat food and they would also do their job. And now let's say we want to create a new default method for all implementations of this interface, but this would be weekend activities. So we would have another default method called get weekend activities. But rather on the weekend, they might do their hobbies and they might visit the shops. So we have two different default methods within our interface. And we can see that they do share actually two methods on their own. So this would be the very specific use case when we might want to use private methods within an interface. So ideally we would encapsulate do sport and eat food into a private method that can then be called for both of these two default methods. So let's create that private method. So now these two default methods can be refactored to just call the get normal activities. And this is where we might want to use private methods within our interfaces to help reduce repeated code that we might find within the default methods that we write within our interfaces. So that summarizes this video on some of the key changes that are introduced with Java 9. So we've looked at some of the different collection factory methods. We've then had a look at some of the ways a stream can now be transformed using off nullable, using take while and drop while. And then we've looked at where we might want to be using private methods within an interface. Do take a look at my video on JShell and also modularity that has also been introduced with Java 9 if you're interested in upgrading from Java 8 to Java 9.